Good day to you. This is teacher Leland, Alejandro, and we're going to study modeling with exponential and logarithmic equations. So we're going to consider problems about compound interest, okay? Compound interest. All right, so let's see the problem set. Okay, it's over here. All right, here's the first number. Here's the first number, and let's read first. Okay. Daniel invests $8,015 in a savings account with a fixed annual interest rate of 6% compounded 6 times per year. What will be the account balance be after 10 years? Okay, so let's have the given first. All right, let's write the given first. So we have the amount invested that will be denoted by P, present value. This will be $8,015. All right. Fixed annual interest rate of 6%. So that would be our small r. This should be 6%. This is equivalent to 0.06 in decimals. Now, number of compounding periods, 6 times per year. That will be represented by the variable m. Okay. That will be 6 periods per year. And then what will be the account balance be after 10 years? So the time is given in 10 years. There. Okay, our formula for final value, that's F is equal to present value times the quantity 1 plus rate of interest per year divided by number of compounding periods. This will be M. There. Okay, let me rewrite my M. Okay, that should be M. There. Close parentheses, raise to the power, the product of M and the time. There. Okay. All right, this is the formula. We shall write the data. So this is equal to 8015 times the quantity 1 plus 0.06 over 6. Close parentheses, raise to the power 6 times the 10. There. Okay, so we can now simplify our numbers. So that's something like 0.06. You divide that by 6. That will be 0.01. So this is equal to 8015 times the quantity 1 plus 0.01 raised to the power 6 times 10, that's supposed to be 60 there. Okay, 60. So this is F 8015 times the quantity 1.01 raised to the power 60. And this will be amounting to, all right, let's compute. This is 8015. You can use a calculator for this. Times 1.01 raised to the power 60, and that will be about 14,560. And 82404, 82404. Okay, we're going to round it. 2 numbers after the decimal point. So this is 14,560 and 82 cents. There. And we can verify the answer. All right, so that's it. $14,560 and 82 cents. Okay, that should be for our first number. All right, just remember this formula. F final balance is equal to amount invested, okay, times the quantity 1 plus rate of interest over number of compounding periods, raised to the power, the product of the compounding period times t. There. All right, so that will be the formula. Let's continue with the second, clearing our first, and then continue with our next problem. Okay, here's our number 2. Shanice invests 7,553 in a savings account with a fixed annual interest rate of 7%, compounded 12 times per year. What will be the account balance be after 7 years? All right, let's write the data first. Invested amount is P. That will be 7,553. All right. Fixed annual interest rate, that's R. That's 7%. And in decimal, that's 0.07. Number of compounding periods, 12. So that'll be 12. What will the account balance be after 7 years? So time is 7 years. Okay, let's go back to the formula. F is equal to P times the quantity 1 plus R over M raised to the product of M and the time. There. All right, so direct substitution, our P is 7,553 times the quantity 1 plus 0.07 over 12 raised to the power the product of M and T. 12 times 7, that will be about 84, right? 84. So we have 0.07 over 12. 0.07, that's 7% divided by 12. That will be 5.83 times 10 to the negative 3, okay? So this is F 7,553, and that's 1 plus to the negative 3, then that will be 0.00, okay? That will be 583333, repeating decimal. Okay, repeating decimals, raised to the power 84. There. Okay, and this is 5, of course. This is 5. Let me rewrite that. Okay, that's a 5 there. All right, let's compute. Times the quantity 1. Okay. Raised to the power 84. 12,311. So that looks like 12,000. Let me put the units first. Let me put the units. All right, 12,311. 34509. 34509. Okay, so rounded to the nearest hundreds. All right, this will be 12,311. 35 cents. There. And we shall verify. All right, that's $12,311.35. So that will be over here. Okay, all right, that will be for our second number. Let's continue with our third. Let me clear the screen. And let's do our third. Okay, here's our third number. Ndiba invests $5,907 in a savings account with a fixed annual interest rate of 3% compounded 4 times per year. What will the account balance be after 11 years? Okay, so we're still looking for the final balance, okay, or a final account balance. So we have the given, and that's present value. That's 5907. Interest rate R, that's 3%. That's equivalent to 0.03. 0.03 compounded 4 times per year. So that'll be our M. M is 4. What will the account balance be after 11 years? So that's our T. That's 11 years. Okay, so Our formula is final amount is equal to present amount times the quantity 1 plus R over M raised to the power, the product of M and the time. There. All right, so we shall remember this formula. Okay, always remember this formula. Okay, this will be equal to 5907 times the quantity 1 plus 0.03 over 4. Close parentheses, raised to the power, the product of M and T. So that's 4 times 11 there. Okay, so we shall just calculate this. So 0.03 divided by 4. That looks like 0.03 over 4 is 3 over 400. So that's 7.5 times 10 to the negative 3. Let's just write it. So this is equal to 5907 times the quantity 1 plus this is to the negative 3. So we have 3 zeros like that, followed by the significant digits 7 and 5. There. Okay. And then that will be raised to the power 4 times 11. That should be 44. Yeah. All right. Let me just compute this. This will be a 5907 times the quantity 1.0075 raised to the power 44. That should be about 8,206. This will be in dollars. 8,206.337,661. Okay. So we can round this. This will be 8,206 and 34 cents. There. Okay, let's check and verify. We have 8,206 and 34 cents. Correct. All right. So that's it. Over here, you can see the red numbers. Okay, confirmation. And we have the next number 4. Let's continue with number 4. All right, let's continue with number 4. Here's number 4. Dan invests $5,430 in a savings account with a fixed annual interest rate of 6%, compounded 2 times per year, semi-annually, okay? 2 times per year. What will the account balance be after 12 years? All right. So we have the given P. This is 5,430, interest rate of 6%. That's in decimal 0.06. And 2 times per year. So semi-annually is M equal to 2. After 12 years, that'll be time. 12 years. Okay. Same formula, F is equal to P times the quantity 1 plus R over M. Close parentheses, raised to the product of number of compounding period and the total time in years. Okay, so this will be 5,430 times the quantity 1 plus 0.06 over 2, the number of compounding period, raised to the product of M and 12. That should be 2 times 12, that should be 24. So we have something like 0.06 over 2, that must be 0.03. So this will be just 5,430 times the quantity 1.03 raised to the power 24. There, okay? And so we shall compute, this will be 5,430 times the quantity 1.03 raised to the power 24, gives us 11,038. This is 11,038,072. This can be rounded to 11,038 and 7 cents. There. Let's check and verify. That's 11,038 and 7 cents. All right, that's it. That goes to our number 4. Let's have our next. Okay, let's have our next. This is number 5. Okay, here's number 5. Chelsea invests $6,220 in a retirement account with a fixed annual interest rate of 4% compounded 3 times per year. What will the account balance be after 18 years? Okay, let's have the given first. Amount invested is 6,220. Okay, interest rate, fixed interest rate, annual interest rate are 4%, equivalent to 0.04. Compounded 3 times per year. That should be M equal to 3 times 18 years. Okay, formula is final amount is equal to present amount times 1 plus R over M raised to the power the product of M and T. So this is 6,220 times the quantity 1 plus 0.04 over 3 raised to the power 3 times 18. There. Okay, we shall simplify this first. 6,220 times the quantity 1 plus 0.04 over 3. That should be about 1 over 75. And that's 1 over 75. That should be 0.013 repeating decimals. Okay, that's 3333 repeat. So it's 0.013333. All right, repeating decimals, raised to the power 3 times 18. That will be 54. All right, that should be 54. Okay, there. All right, so let's compute. This will now be, okay, 6,220 times the quantity 1.01 and then repeating decimals. Okay. And then raised to the power 54. And we have something like 12,717. 12,717, 92164. And this is rounded. This is 12,717, 92 cents. There. Check and verify. Let's have the answer. 12,717 and 92 cents. All right, we're correct. You can verify it over here. All right, that means that's the right final amount. All right, let's continue with the next number. Okay, here's the next. Let's read the problem. Sarawong invests 3,936 in a savings account with a fixed annual interest rate of 5% compounded continuously. What will the account balance be after 5 years? Okay, so this time, this is continuous compounding, okay? Continuous compounding. We have a different formula for continuous compounding. So we have the formula for continuous compounding is final amount is equal to the present value, okay, multiplied by E raised to the power rate times time, okay? That's the formula there, okay? All right, so that's present value multiplied by E, okay, raised to the product of R and T, where R is the rate of interest and T is the number in years, the time in years. Now, how about the E? E is equivalent to 2.71828. Okay, that's the natural base in Napierian logarithm. Okay, so you can see the exact value. Okay, that will be something like 2.718281828. Okay, the E is equal to the calculator value is 2.718281828. There. Okay, that's the constant, the Napierian base. Okay, okay, under natural logarithms. All right, so let's solve. Okay, let's enumerate the given. Our present value or amount invested is $3,936. Okay, fixed annual interest rate of 5%. And this is 0.05 in decimals. And then our given time after 5 years. So this will be after 5 years. There. Okay, so this will be like F is equal to P 3936 multiplied by E raised to the power the product of RT. So you can use the constant here, 718281828. Okay, that's 718281828. All right, and then this is raised to the power R times T. Okay, R times T. All right, so this will be R, that's 0.05, the product of this and the 5 years, okay? Like that, and like that, okay? All right, so you have to use your calculator here because it's exponential. All right, so let's have the calculated value. This is 3936 multiplied by E, okay, raised to the power 0.05 times 5, there. And the calculated amount is 5,053, okay? So this is F in dollars. This is 5,053, 92404, 92404. So we can round that. That will be $5,053.92. Okay, there. All right, let's check and verify. So the answer is over here. There, $5,053.92, exactly what we have over here. Okay. All right, so you have to make use of the constant in your calculator for continuous compounding. All right, that's 2.718281828. All right. Okay, you can find that in the calculator. Okay, so you don't have to memorize it. All right. Okay, so let's have the number 7. All right, let's have number 7. Okay, let's continue with number 7. Okay, Ted invests 7,436 in a retirement account with a fixed annual interest rate of 9%, compounded continuously. All right, the moment you see that word there, continuously, you will use a different formula. Okay, what will the account balance be after 16 years? All right, so, all right, the given is P, that's 7,436, and then interest rate is 9%, 0.09, okay, and then compounded continuously. Time is 16 years. Time is 16 years. There. That should be years. All right, and so we have the formula F is equal to P times E raised to the power RT. There. Okay, and so this is P at 7436 times 2.718281828. There. 281828. 2.718281828. All right, raised to the power R times T. Okay, our R is 0.09. We're multiplying 0.09 and the time 16. There. And then that will be one piece over there. Okay, and then the rest, you can use your calculator. All right. So this will be 7436 times the quantity. You get the E there, raised to 0.096, 0.09 times 16. And that's it. That will be 31,385. So this is in dollars, 31,385.0941. Okay, you can round that. That will be 31,385 and 9 cents there. Okay, so let's check and verify. That's $31,385.09. All right, so that's it. You can see the red numbers here. Okay, that shows our answer. Okay, just remember, when you see the continuously in a problem, compounded continuously, you are going to use this formula. Okay, that's the formula. All right, next, let's have number 8. Let's clear the screen. Let's continue with number 8. All right, here. Gabriela invests $3,354 in a retirement account with a fixed annual interest rate of 3% compounded continuously. What will the account balance be after 13 years? All right, you can see there compounded continuously, so you know what formula to use here. All right, so the given, we have the amount invested at 3,354. That's 3,354. Fixed annual interest rate of 3%. So this is 3%, equivalent in decimal of 0.03. Time is 13 years. Yeah. Okay, so our formula is different from the problems 1 to 5. This will now be P times E raised to the product of R and T. Okay, all right, there. Remember, this is the constant E raised to the product of R and T. It's like that, okay? All right, so just a little clarification there so you won't be lost in using the formula. All right, so this is 3354 multiplied by 2.718281828, something like this, raised to the product of R. That's 0.03 times time of 13 there. So the product of 13 and 0.03, okay, like that. All right, let's compute first. Let's, okay, let's compute 3354 times E raised to the power product of 0.03 and 13 years. That will be about, okay, $4,953 and $79. Okay, so that will be 4953 793583 3583. So I'll write everything and then round it, okay? You don't round anything while you're computing. You will have errors. All right. So this is 49. You're going to round when you reach the final answer. So this is 79 cents. All right. Let's see the answer. That's 4,953 and 79 cents. All right. Exactly what we have. So this is correct. All right. Let's go to the next one, number 9. Let's have number 9. Okay, here's number 9. Ndiba invests 4,442 in a retirement account with a fixed annual interest rate of 7% compounded continuously. There. So we still have the same formula. Let's write the given first. This is 4,442. Interest rate, 7%, equivalent to 0.07. What will the account balance be after 14 years? There. Okay, so this is compounding continuously. Our formula is F is equal to P times E raised to the product of R and T. Okay, all right. So at this point, we already know how to use that. This is 4442. Okay, this is 2.71828. Okay, 2.718281828 raised to the product of 0.07 and 14. So this is 0.07 and 14. There. All right. And so this will be computed. All right. Okay. So just have to use your calculator here. 4442 times E raised to the product of 0.07 and 14 years. All right, and you have something like 11,835. So that is in dollars, 11,835, 51463. And we can round this. This will be 11,835 and 51 cents. Okay, there. 11,835 and 51 cents. We can verify the answer. All right, that's 11,835 and 51 cents. All right. That's it, up to number 9. Let's continue with the next. All right, let's clear the screen. Let's have the next problem. All right, Ryan invests 6,043 in a savings account with a fixed annual interest rate of 3% compounded 4 times per year. How long will it take for the account balance to reach $6,810.41? All right, so this time we're looking for time, okay? How long will it take for the account balance to reach $6,810.41? Okay, so this is not continuous compounding. We have their compounded 4 times per year, okay? So we're looking for time here. Now we're going to use the formula. So we're going to derive the formula first. All right, so let's just have it on the screen. All right, so this is F is equal to P. We're going back to this formula, 1 plus R over M raised to the product of M and T. All right, we're after the time here, okay? All right, so we're going to do a literal equation here, So this will be, let's start dividing both sides by P. So we divide, remember this is the formula, okay? This is the formula, okay. Now we're after that letter T, the time. Time equals something like that, okay? All right, so we're going to solve for T. All right, so let me remove that box. So we shall divide by P first. Let's divide here by P and divide this by P. Okay, this way, this cancels out. There. and we have f over p that's equal to 1 plus r over m raised to the product of mt. Okay, here. Now, if you apply logarithms to both sides, if you're going to apply logarithms to both sides, we're going to have logarithm of f over p. Okay, this is one quantity ratio. Okay, logarithm of f over p, and this is a logarithm of 1 plus r over m raised to the power mt. Okay, and this will be equal to, all right, the logarithm of f over p. Okay, that mt over here, this part, all right, will now be in front, following the logarithmic properties. Okay, times log of 1 plus r over m, there. Okay, and so we move this particular exponent in front, becoming a coefficient. At this point, we can now divide both sides by this amount here. We can now use this amount as divisor so that we'll be able to isolate m and t. Okay, m and t. All right, so let's remove the boxes and circles that I placed. Let's remove that. Okay, all right. If we can only divide by the numbers and leaving that letter t there, then we'll be able to get the formula. Okay, all right. So at this point, we will divide there. We're going to use the divisor log of 1 plus r over m, there. Okay, together with the m, okay, so that we will be having just the t on one side of the equation. So let's put the m here, part of the divisor, being multiplied by the logarithm, and then use it also in the other side. Okay, we will be dividing the other side by the same. M times logarithm, okay, of 1 plus r over m, there. Okay, so after doing this, you will see this part here is a number cancel out with this number. Also, this m cancels out with this number. And so the right side is just t. Okay, the right side is just t. All right, so we can now have the formula equivalent to the left. Okay, equivalent to the left. Therefore, t is equal to, all right, let me put the t at the left, and then the thing at the over here will be at the right. Okay, all right, so that will be our formula. So this is equivalent to t. All right, this is logarithm of the future amount over the present amount divided by the product of m and the logarithm of 1 plus r over m, there. Okay, that should be our formula. Okay, that should be our formula. All right, let me write that over here. Okay, so I can see it over here. All right, so we have that formula, and that's what we're going to use here in number 10. All right, so let me just erase this part so that we will have some space. Okay, I hope you will be able to get that. All right, that's logarithm of the ratio. Okay, final amount over amount invested. Okay, divided by, all right, that will be divided by the product of the number of compounding period and the logarithm of the sum of 1 and the ratio r over m. Okay, all right, this formula, all right, this is the formula. There. All right, so let us use that formula to solve this problem. All right, let me just clear. Let me erase this part. Okay, the part that we are not going to use. All right, so let me just erase it. I'm not going to erase the entire screen because we need the formula. All right, so we need the formula, and you need to see that formula. All right, so let me just clear the screen. All right. Okay, let's write the given first. Ryan invests 6,043. That's the amount invested. That goes to the P. And that's 6,043. All right. Savings account, fixed annual interest rate. So that's R. And that's 3%, equivalent in decimal 0.03. Okay, 0.03. Compounding period, 4 times per year. So that's our M. And that's 4 times per year. All right, how long will it take for the account balance to reach $6,810.41? That's the final amount there. So this is in dollars, 6,810 and 41 cents. Okay, we're going to apply this formula. Okay, the formula over here for after the time. And this is logarithm of the ratio of the F 6,810.41 over P 6,043. There. And then this is to be divided. Whatever amount here will be divided by the product of M. Okay, our M is 4. Following the formula here, you have M there. That's 4 times logarithm of 1 plus, okay, our R is 0.03, all right, over M. So the same M, 4, there. All right, so let me just simplify this part, and then divide, okay? And that will be our time in years. All right, so let me compute. All right, so that will be a logarithm of 6,810, and then the other number is 6043. Okay, all right, so let me just write it first. Okay, so that actually is 0.051920. Remember, do not round, okay? While you are computing, do not round. And then this is to be divided by, all right, the equivalent of the number at the bottom. All right, so this is 4 times logarithm of 1 plus 0.03 over 4. Okay, that will be equivalent to 0.0129, 0.0129, 80219, 8021925. Okay, that's the number at the bottom, okay? That's 4 times logarithm of the sum of 1 plus 0.03 over 4, okay? All right, let's compute now the time in years. All right, so this will be our divisor. We have 0.051920, 66383 divided by this number. All right, we have 4 years, okay? 4 years. The result is something like 3 and 999983577, and we can round that to 4 years. So this is 4 years there. Okay, let's check the answer. Let me remove the formula here. Let me just remove the formula here. All right, that will be Because the answer will be placed here, let's remove the formula. Okay, let's see the answer. Okay, there's the answer. Okay, that's 4 years. Okay, all right, so that's it. That goes to our number 10. Let's continue with the next number. All right. All right, here is number 11. Daryl invests 5,477 in a savings account with a fixed annual interest rate of 2% compounded 6 times per year. How long will it take for the account balance to reach 6,555 and 20 cents? Okay, so let's have the given first. We have the amount invested at 5,477. Okay, annual interest rate of 2%, so R is 2%, and this is 0.02. Compounded 6 times per year, that will be the M, and this will be 6 times per year. How long will it take the account balance to reach F, which is 6,555 and 20 cents there. Okay, so we have our formula. We're looking for time, okay? How long will it take for the account balance to reach the final amount, 6,555 and 20 cents. So T is equal to the logarithm of the ratio F over P divided by M times the logarithm of 1 plus R over M. There, that's the formula we derived, okay? All right, so, okay, that's it, all right. Okay, all right, substitute the given data, direct substitution, and then we calculate, okay? So this will be T, all right? The logarithm of the ratio of the values 6,555 and 20 divided by 5,477. Okay, divided by the product of 6 and the logarithm of 1 plus rate of interest is 0.02 over M of 6 there. Okay, so you have to calculate and use your calculator. And this will be 2 numbers, okay? Let's compute this part, and after the division symbol, write that one, okay? All right. So this is logarithm of 6,555, 20 cents, and you have 5,477, okay? And that's equivalent to this number. So that's 0.07804.3, that's 8, okay? 804320.568. There, okay? All right, that will be our numerator. Now let's have the denominator. That will be 6 times logarithm of 1 plus 0.02 over 6. Okay, this is the denominator. Okay, this is the denominator. It's 0.0086714. 8671445. Yes, all right. So we're going to use this as our divisor. So this divided by, all right, we have exactly 9 years. Exactly 9 years. There, okay? That's the answer. All right, we can check and verify over here. 9 years. All right, there. Okay, that will be for our number 11. Okay, that's the answer. Let's continue with number 12. Okay, you have to memorize the first formula and just derive this formula. Okay, there. You only need to memorize one formula and then do literal equations, solve a letter in terms of the other. Okay, that's what we did in the first part of the previous number 10. All right, let's continue with 12. Okay, let's continue with number 12. All right, here's number 12. Julia invests $7,369 in a savings account with a fixed annual interest rate of 4% compounded 4 times per year. How long will it take for the account balance to reach $10,131.94? All right, so the question here is how long? Okay, so we're looking for the time. Okay, all right, and there's not a word continuously. So this is the ordinary. Okay, all right. So we are going to have the data first. Amount invested, P, that's $7,369. Okay. Interest rate, annual interest rate is 4%. So this is 4%. This is 0.04. Okay. To reach the balance of 10,100, that should be about, all right, this will be our F, okay? This is our F. This is 10,131 and 94 cents. What else do we have there? Okay, interest rate is 4%, that's 0.04. Compounded 4 times per year, so quarterly. That's our M, quarterly, okay? And so we can now use the formula. Okay, let's use the formula. All right, we're looking for time, okay? We're looking for time, okay? How long will it take for the account balance to reach $10,131.94? And that formula is the one we derived a while ago. That's logarithm of the ratio of final amount over present amount divided by the product of the compounding period and the logarithm of 1 plus R over M. There. All right, so this will be equal to logarithm of F. Let's get our F. 10131.94. Divide this by P, 7369. Logarithm of that ratio will be part of the numerator. Okay, and then from the formula, we have the M, that's 4. 4 times the logarithm of 1 plus 0.04 over M equals 4 also. There. So we can now compute. Okay, so let's compute. All right, let's have the first part here. Okay, separately computed. That's logarithm of the ratio 10131 and 94 cents and 7369. There. That's equivalent to 0.13828 40528. There. Okay, you can just recalculate later. Okay, all right. So that's 1382840.528. That's our numerator. All right, let's have the denominator 4 times the logarithm of 1 plus 0.04 over 4. That will be about 0.0172. Okay, 85495. 8549513. There, that will be our divisor. Okay, so we will just divide this divided by this one. That's equivalent to 8. There. That's equivalent to 8 years. Is it 8? Let's check. Yes, it's 8. Over here, the red writings there, 8 years. All right, so that goes to our number 12. Let's continue with the next. All right, number 13. All right, here's number 13. Trayvon invests 7,981 in a retirement account with a fixed annual interest rate of 2% compounded 2 times per year. How long will it take for the account balance to reach $10,545.22? How long? All right, so we know we're looking for time, okay? All right, so there's the question. How long will it take that one? So we're looking for time here. So same formula, okay? Same formula. T is equal to logarithm, all right, F over P over M times logarithm of 1 plus R over M. There, okay? All right, let's get the data. Amount invested is P. That will be 7981, 7981. Okay. Fixed annual interest rate of 2%, so that's R. 2%, equivalent to 0.02. 2 times per year, that will be the compounding period. Semi-annually, that goes to our M. Semi-annually, there. Then we're looking for time. We have to find the time to reach the amount F. Our F is given $10,000, 545 and 22 cents there. 10,545.22. All right, direct substitution. We're going to use this formula. Okay, we're going to use this formula. All right, let's continue with that formula. This is now equals logarithm of F. Our F is on top. So 10,545.22 over the divisor of that ratio, 7981. There, okay? And then at the bottom you have M, that's 2, times logarithm of 1 plus 0.02, that's the R, over the M, which is 2. There. Okay, so let's continue there. Okay, let me just complete my line there, all right. Okay, so let's get the logarithm of the ratio of the 10,545 and 22 over 7981, the logarithm of that ratio. All right, so let's compute first. Logarithm of the ratio of 10,545, 22 over 7981. Okay, that amounts to 0.12009983338. All right, that will be our numerator. Okay, let's have the denominator. All right, this will be expressed in fraction, okay, or ratio. All right, ratio. All right, so this will be 2 times logarithm of 1 plus 0.02 over 2. That gives us 0.008642786427 47565. 47565. All right, so we're going to divide this and that's it. We shall have the T. Okay, all right, so that gives us our divisor. Let's divide. We have something like 13.99998,472. And we can round this to 14 years, okay? This will be rounded to 14 years, okay? All right, so let's verify the answer. Okay, it's 14 years over here. All right, and that means we are correct there. All right, so that goes to our number 13. Let's continue with the next. Let's have number 14. All right, here is number 14. Wilbur invests 5,532 in a savings account with a fixed annual interest rate compounded 2 times per year. After 4 years, the balance reaches $6,740.20. What is the interest rate of the account? What is the interest rate of the account? This time we're looking for the interest rate, okay? We're looking for the interest rate. All right, so we're going back to the formula. All right, our basic formula, future amount equals present amount, 1 plus R over M, raised to the product of the compounding period and the total number of years. Okay, what are we looking for this time? What is the interest rate? Okay, so we're looking for R here. Okay, so we're looking for R. All right, so we have to solve for that R. Okay, there. All right, so we can divide. The plan goes like this. We divide by P, and then we will have F over P. And then we apply probably logarithms, okay, something like that, or exponentiation. All right, so let's get the R over there. So we shall divide by P first. So we have F equals P, 1 plus R over M, raised to the power MT. Okay, if we divide by P and divide this by P, this cancels out. And we have F over P is equal to 1 plus R over M, raised to the power MT. There. Okay, so the R is right there inside the parentheses. So if we will just raise to the power 1 over MT, then we will be able to extinguish the MT here, like that, okay? I'll show you what I mean. All right, it's supposed to be like this. All right, if we raise this to 1 over MT, 1 over MT, and also raise this to 1 over MT, then this cancels out there, okay? All right, and we will have the left side, F over P, raised to the power 1 over MT, there. And now the right side will just be 1 plus R over M, there. So we were able to isolate the R, it's here. So we will just subtract 1 from both sides and multiply by M, and we have the formula, okay? All right, so let's continue. Let me just remove my check there. All right, so the next thing we do here is subtract the 1, okay? Subtract the 1. And then the left side will become F over P raised to 1 over MT minus 1, okay? And the right side is R over M, okay? So if we shall continue over here, so I'm showing you the derivation, okay? If we shall continue over here, then this will be F over P raised to the power 1 over MT, there. We subtract 1, and we subtract 1 from both sides. This 1 will disappear, okay? And so the right side will just be R over M, there. Okay, we're almost done deriving the formula. We only need to multiply by the M, okay? Multiply it by M. So if we multiply this by M, we will have M times m times the entire quantity f over p raised to the power 1 over mt minus 1. Okay, the entire quantity at the left side multiplied by m. Now, this will be equal to r over m. Multiply this by m also. And this cancels out there. And so the formula for r, okay, I will now exchange places. I will put the r here. And this is equal to the entire left side, m, times the quantity f over p raised to the power 1 over mt minus 1. There. Okay, that's the formula for rate of interest. Okay, all right, so I hope you were able to get that. Okay, all right, so that's the formula. That's the derivation. All right, now let's use it in the problem. All right, okay, I'm going to erase everything except the last writing there at the lower left. All right, so we will not use the clear the screen. We will use the eraser, so we'll be able to have that particular formula that we have derived. All right, so let's erase up to this point and up to this point. Okay, let me just erase. All right, that's the formula over there. Okay, we're after the rate of interest. Let's write the given data. All right, our given data, Wilbur invests $5,532, 5,000. So that is 5,532. Okay, savings account with a fixed annual interest rate compounded 2 times per year, compounded 2 times per year. So compounding period is given, that's 2. After 4 years, that's T. After 4 years, the balance reaches $6,740.20. That should be your F. And that will be 6,740 and 20. All right, we're looking for the interest rate. What is the interest rate of the account? We have the formula over here, okay? All right, okay, so we're going to use the formula, all right? All right, let's use the formula. We have M, we have F and P, we have the T, and therefore we can use this formula, okay? All the numbers that we need at the right side, okay, are present. Okay, so let's use the formula. We have R, okay. We have M, that's 2. Okay, we're following this. We're going to follow this. So we have equals 2. Okay, we put that particular grouping symbol and then the parentheses. All right, let's write the F. Our F is 6,740 and 20. Okay, divided by P, that's 5,532. Okay, close parentheses. Raised to the quantity 1 over the product of M and T. Okay, the product of these two. Okay, that's 2 times 4. 2 times 4 there. That's one quantity exponent. Okay, that means 1 over 8. Okay, and then minus 1 there. So you compute this first and then multiply it by the number 2. Okay, the number 2 is right there. Okay, all right, so we shall do that. Okay, so this will now be R. Okay, so let me do the calculation. So we have there 6,740.2 divided by 5,532. Okay, all right, so I will write it part by part. Okay, so this is 2 times, and after dividing these two numbers, okay, we have this 1.21 840 2025. And this number is now raised to the power 1 over 8, okay? Or 8 root, okay? 8 root. All right, and then after that, minus 1 there. Okay, so this will be raised to the power 1 over 8 and then minus 1. So this is R. You have 2 times the quantity 1.02 for 99908 minus 1 there. Okay, so we subtract the 1 and then times 2. Okay, so minus 1 and then times 2. And the R is equivalent to 0.0499981641. And that looks like 0.05. Okay, and 0.05 is 5%. There, 5%. Okay, R is 0.05. Okay, rounded, and that will be 5%. Is it 5%? Let's get the confirmation here. Yes, it is. All right, over there. You can see the answer over there. All right, so that goes to our number 14. Let's continue with the next. All right, let's continue with the next number. All right. So that will be, yes, that will be for number 14. All right, let's continue. Okay. All right, let's have the number 15, probably our last number. All right, let's clear the screen. Okay, here's number 15. All right. Imani invests 5,972 in a savings account with a fixed annual interest rate, compounded 6 times per year. After 5 years, the balance reaches $8,457.52. What is the interest rate? What is the interest rate? All right, let's have the given. All right. Amount invested is P. That's 5,972. All right. Compounded 6 times per year. So that will be the compounding period. M, that's 6. And then after 5 years, so that means our T is 5 years. Yeah. The balance reaches $8,457.52. That should be our F. That will be 8,457.52. All right, what is the interest rate? Okay, so we're looking for R here. So what's the formula? R is equal to M times the quantity. All right, this will be F over P raised to 1 over MT minus 1. Okay, that's the formula, right? Okay, F over P, yes, all right, that's it. All right, F over P raised to the quantity 1 over MT minus 1. M times T, okay? That's M times T. All right. Okay, so let's substitute the given data. This will now be 6. And then we use the square brace and then parentheses, use the F now. 8,457 and 52. Then you divide this by P, that's 5,972. And then this is raised to the power 1 over M, that's 6 times the T, that's 5. Okay, all right. That will be one quantity. That's 6 times 5, so that will eventually be 1 over 30, okay? And then whatever quantity we get here, minus 1 before multiplying by 6. Okay, so let's do it nice and slow. This will be 6. Okay, let's divide first. Okay, so we're going to have there 8457.52. That's 0.52, and then that should be 5972. And that's equivalent to 1.416. This is 1.416, 1955.79. 1955.79. This quantity is the ratio of the 8,457.52 over 5972. Now, this is raised to the power 1 over 30. There. That's 1 over 30. Okay, and then minus 1. All right, so we're going to raise this to 1 over 30. And we get some amount. And this is 6 times 1.0116. And then this will be 6 more digits. And the 8 there. So how many number 6? That's 1, 2, 3, 4, 5, number 6, and the 8. All right, then minus 1. Okay, and so we subtract the 1 and then times 6. Okay, so the answer is 0.07000000. So that will be 636. All right, that looks like 7%. Okay, let's check and verify. There, 7%. And that's it. That will be our 15th example. I hope you were able to learn something about compound interest. We're going to do another topic of this in another time. So I hope you were able to learn. This will be all for now. Bye-bye.